The coordinate system connects geometry and algebra, making vectors tangible and visible. Before introducing the Cartesian coordinate system, let's first consider a simple mathematical concept, the number line. A number line has three key elements: an origin, a positive direction, and a unit length. A number line is an infinitely extending straight line. On a number line, each point corresponds to a real number. If we position two number lines perpendicular to each other so that they share a common origin, we then create a two-dimensional Cartesian coordinate system. In this two-dimensional coordinate plane, every point can be written in the form x1, x2. x1 represents the horizontal position, while x2 represents the vertical position. A two-dimensional column vector x1, x2 can be seen as an arrow with its tail at the origin 0, 0, and its head at x1, x2. Still using RGB color model as an example, we can represent the horizontal and vertical directions with red and green respectively. Together, they construct a red-green plane. When dealing with a small number of vectors, or when we care about the locations of their heads and tails, we typically represent vectors using arrows. However, when there are many vectors, we can use scatter points to represent vectors directly. In this case, it's assumed that all vectors originate from the origin, and the scatter points indicate their endpoint. In this red-green plane, two special vectors are worth noting. The first one is a unit vector, 1, 0, in the pure red direction. We call it E1. Please note that a unit vector has a length of 1. The other unit vector, 0, 1, is in the pure green direction. We call it E2. Any vector in this plane, such as x1, x2, can be decomposed into x1 times E1 plus x2 times E2. In other words, these two unit vectors, E1 and E2, serve as the framework that creates all vectors in the plane. This ability is called span. If we add a new number line at the origin, making it perpendicular to the existing two axes, we then get a three-dimensional Cartesian coordinate system. A two-dimensional coordinate system is like a canvas painted with red and green. The addition of a third dimension brings in blue, allowing us to perceive the full spectrum of the RGB colors. Now we have seen how vectors are represented in coordinate systems. Next, we'll discuss vector addition, subtraction, and see how these operations bridge geometry and algebra.